We're going to take a look at solving linear systems graphically. This video assumes that you have some skill with graphing in terms of graphing the equation of a line. Also, that will be reviewed mildly as the video progresses. When we are dealing with a linear system, we're dealing with two equations of lines, and we will graph them and find their point of intersection. The point of intersection is the solution of the linear system. It is the answer to this question. The steps we're going to follow here are step 0, put each equation in slope-intercept form. Step 1, graph each equation. 2, find and state the point of intersection. Again, I tend to use the notation of step 0 in problems where that step is something you should look to do, but it's not always something that you will have to do. So if we notice here in our equations, I have two. The top one I'll work with in blue, the bottom one I'll work with in red. And we see here that neither of these equations are in slope-intercept form. And don't forget, slope-intercept form is in fact y equals mx plus b, where m is the slope and b is the y-intercept. Okay, so examining the top equation, to turn it into y equals mx plus b form, the first thing I'll have to do to get y by itself is subtract 2x from both sides. This will give me 5y equals negative 2x plus 15, which is the same as 15 minus 2x. But again, the form we're dealing with, we would like the x term first, the constant term last. So just one more step. I divide by 5 on both sides, get y by itself. That will give us y equals negative 2/5 x plus 3. Now the second equation, which I'll work with in red, also is not in slope-intercept form. So we see here, to get that in slope-intercept form, I'll need to get y by itself, and I will just simply one step add x to both sides, which will give me y equals x plus 4. Again, x minus 4, because again, the x term is positive, the 4 term is negative. I can write them in any order I want, as long as I keep the appropriate sign with them. Okay, so that's step 0. Moving on to step 1 is graph each equation. Again, I've said that we are making the assumption that you can graph the equation of a line. Let's just take a look at those steps. It's going to be to graph the y-intercept, apply the slope, connect the dots. Well, I'm going to use this little graphic organizer here that I have that will help me identify the y-intercept and as well as the slope. The y-intercept is b, and we see in this equation that is in fact 3. And then we also see that the slope m in this equation is negative 2/5, which implies going down 2 and right 5. So we will now make that graph by doing step 1a, graph the y-intercept. So we take 3, go to the y-axis, and graph a dot. Applying the slope would be to, from there, go down 2, and then right 5, and we will in fact graph another dot. If I repeated that by going down 2 and right 5, you'd see I'd be off the chart. So if I wanted to make, in fact, 3 dots for this this line, I can start back at my y-intercept and go up 2 and left 5, which in fact is also the application of the negative slope 2/5. So then I'm going to take my straight edge, and it's very important when you do these problems that you use a straight edge while connecting the dots. And it's very important that you try and go through the grid intersections, not just the dots. You really need a sense of precision here, because you're in fact going to be graphing two lines and looking for a point of intersection. So having some precision here is very important. So that is the graph of the blue equations. Now for the red equation, similarly, I'm going to use this little graphic organizer, and I'm going to see that the y-intercept is -4, and my slope here is the multiplier of x, which in this case is 1. It's not a bad time for me to say 1 over 1. That's not the final answer to the problem, so it doesn't have to be simplified. And writing it this way is a good strategy, because then it shows me that I'm going up 1 and right 1. So again, taking a look at the steps, we're going to graph the y-intercept, which here is -4. So I go to the y-axis and graph a dot at -4. Then I'm going to apply the slope. So in this case, it's go up 1, right 1, put a dot, up 1, right 1, put a dot, up 1, right 1, put a dot, up 1, right 1, and I can continue that. By doing so, you see I actually just hit the point of intersection, so I can somewhat anticipate the answer here. Okay. Then again, going to take my straight edge, and I'm going to make sure that I connect the dots with a nice long line as precisely as I can, going through the grid intersections. And noting the point of intersection. So we see here that I've graphed both lines, and now I need to find the point of intersection, which will be in fact the solution. And the solution here looks like it's going to be 5, 1. That is the point of intersection of the two lines, making it the solution to the linear system. The problem is now, in fact, done. And just note that it can be checked by, in fact, taking x and y and plugging it into the original equation. So you would take your x and plug it in here, your y and plug it in here, and you would see when you work that expression out by simplifying it, you would in fact get a true statement. It would be equal to 15. And again, taking your x value, plugging it in here, taking your y value, plugging it in here, and seeing that you do get in fact -4.